All right, success. We have one of the first points of getting a locator service to functionally work with Unity's recompile and continue playing feature. This is great, considering that most uses of statics, or pretty much all use of statics, is just eradicated from being able to support that feature. However, it does, of course, require some changes to how we think about a locator service. And granted, we're diving into an area where there could be dozens of solutions and alterations and different ways of approaching this. So right now, I'll show you one of the ones that I came up with. And I may dive down more areas of it, and I may also try simplifying it down a little bit more. I think there's some areas of the code that I can effectively just get rid of, but I haven't validated all of it. What I have here is a happy path showing a locator system working. Now, to begin with, what I want to show you on this is that I have an object here called root. This is something that I had seen some other studios doing, but I had never done myself. And so I felt like this option can work, and it would certainly solve the idea of a locator service. So the idea is that I have a locator class. Now, the locator class, in this case, I actually built it so it can be in multiple places at the same time. The idea is that at any point in time, you ask for an instance of the locator from your lineage going all the way up to the root. So if we are score the path on here, where is our path? Oh, usually I thought it used to have a path down here where it would actually say what you've selected. Oh, is that just this stuff? It says the path here. Okay. Well, whatever. So the path on this one is score underneath canvas underneath root. So on this one, I have a locator script here on canvas, and I have one here on root as well. And one of the big things about this is that I am not setting these values. I am not establishing these at design time. I want the locator service to be able to do it for me. Now, there are some areas I'm going to dive into later on this, and that is the idea of actually getting rid of a lot of the locator service here, and effectively changing it out with something that says, what are all the fields that are missing, and having a system of rules just to go through your scene and automatically wire everything up. Guarantee that everything is wired up properly so that when the scene starts, everything is already cross-connected in ways that support Unity. And I do that on one of my client projects right now, but I can't share all the details into that, so it'll have to be a separate test project later, or a separate test element of this project later. Okay, so a couple things that are in here. When we click on this cube, which, let me just click scene, and on the scene it has a score maker. It has a reference to a scorekeeper, which is empty to begin with. If I click this, I can find it under here, but I don't want to set it right now. Same thing with locator. I have multiple locators in here. Okay. So I have what this, this object, when I click on it, is supposed to trigger an increase of score by 1 point to our scorekeeper. And over here on our canvas, we have a score object, and I have our scorekeeper right there. It's attached to it. It has a reference to itself for the Text Mesh Pro, and then it holds on to the score. Okay, pretty straightforward. Let's play this and actually see it working. So first of all, when I connected this, over here, we don't see any extra references or anything, so it's hard to tell on that one. But if I click on cube, you can see that the locator on root was selected, and over here, the scorekeeper was also found. So the locator service effectively found that for us and wired it in. All right. So now if I click on this, we see our score starts going up every time I click on it. Simple little score factor here. Okay, so I have something happening in one place, triggering code in another place. Now, to test if this actually works, I need to go into the code and make a change. Oh yeah, I suppose it helps if I actually load one of these. So I have the score maker, and I'm just going to put some extra line of code in here. Debug.log get locator was called. There. All right, so I just saved the code, and I'm returning to Unity. It's recompiling this. Now, when I run this, if everything was happy, I should be able to start clicking on that cube again and expect it to work. And it does. Now, it feels a little bit like a cheat. Like, the point of this is, like, here's kind of the obvious way of making it work, in a sense, when we look at it this way. Any of these references will be maintained. Any of those references will be maintained from scene to scene, or from recompile and continue playing. So all of those are there. In addition, I can take a look at our locator class, and let me see if I can get this to debug. No, the map is still vacant for debug. All right, so I'm going to get let's just go back to normal view since I don't get any special details out of it. And let's take a look at the actual code, what the structure of this is. Okay, locator in this case is very simple. In one of the previous videos, or if you take a look at some of the astatics ones, I had a locator in there that is very close to one that I continuously bring into projects with me, where you can set it up by constructor, you can set it up by type, you can set it up by late binding. All right, anyway, but you can set up all those different ones, and you can pull it in, and it's pretty flexible and powerful for how small the project is. Okay, so here's score maker. Let's go find that one. There we go, locator. This is the big one. So one is, you'll notice that I have a private static instance for locator. Was I actually using this one? I don't think this was ever used. Let me just do a quick check on here. Find all references. It says there is one. No. Without reference, symbols without references. Not applicable. Okay, yeah, whatever. It's not applicable. There's nothing that's using this. So I'm not using that static field anymore. Okay. So inside of here, let's see, there's a couple key functions. Some of it I don't really need to get into all the details of. The key thing on it is that we have a set function and we have a get function. There's also this one where we say get, this is a static get call, and we pass in a locator, which can be null, and a transform. This is where any object inside of the system can say, hey, find me a locator, get me a locator. So what it'll do is it first says, hey, if the transform that we're claiming this is attached to is null, then don't get it. We're not actually on an object. Why might we end up running into that? Well, if we're traversing up the tree by parent, one of the things that happens is that if there is nothing on that root object, like if it goes all the way up the lineage, the last parent that it has there, when we say that root element and get its parent, that parent item is going to be null. So that's a reason why we might have a transform is null. Okay, anyway, so that means we're beyond the root, typically. There could be other reasons. Okay, so next I'm just doing another thing. If the locator already, if we passed in a locator, great, then just return that locator. That's exactly what we need. In fact, that code should be up here. Control X. I'm going to paste it here. I'm going to save that because is my code still running? I'm changing my architecture code here. Click, 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 click. Still working. All right, cool. All right, so if the locator already is a locator, that's going to return that one. Next, it checks to see, okay, for the object, are we already on an object? The Unity has the function get component and parent, which basically says take the parent object, take a look to see if it has this component. If it does, return it. If not, try the next one, and then try the next one, etc., until you return it or get to that end of the chain. And that works great, but it doesn't test the actual object you're on to begin with. So you might already be in an object that has a locator on it. Okay, so the first thing we do is actually just check the object we started with. Does that have a locator? If it does, great. Return it right away. We're done. Otherwise, do the one where we actually check out the locator by the actual object it's from. So, or where we start checking it by the parent. We use that parent component call. So we're checking to get the component B locator in any of these. Now, of course, it would just be called locator or something else like that, not B locator. Then the additional A's and B's that we see in here are just to organize different sections of tests. Okay, so then I do one extra thing in here. I have something called set parent. One of the features that I wanted on this is that if this doesn't know what the answer is, then it will pass you on to the next one in its lineage. So if I take a look at get, the first thing it's going to do is say, oh, hey, this dictionary, which, yes, I'm using a dictionary here of types and objects. If it doesn't contain this key, or if it contains this key, then let's just return the value that it has for it right now. We can just return it and we're done. Next, we're going to do a check to see, have we checked for a parent already? Have we checked to see if there's another parent object to this locator? If not, then it calls the function that sets it. And that's just, again, going up that lineage above it to try to find the next locator in line. And this is done through late binding, usually because we might never need to use it. Okay, then on this one we have, once we've done that, if we have not checked for the parent, then we do this, and that sets the variable to true, but it also checks the parent and sets the parent value. If we tried checking it, which by this point we have now checked for parent, if it's null, then we just return null right away. And then finally, we tell the parent locator to try getting that type. Now, the same thing is going to happen to that parent. If that parent can't find it, it's going to try to call its parent, etc., to see if there's another locator. So that way you can go all the way back to root. Okay. Let's save that. The set function has something pretty similar where, one, we just set the value right away. So whatever we get, if you're not familiar, just to clarify, this setter format does both add and update in Unity or in C#. So I can just say this, and if it doesn't exist, I'm already setting it. Okay, so we just set the value of what it's expected to find in this locator. However, I also have this other one, this optional variable at the end, toRoot. If I expand this out, toRoot, when it's true, every bLocator reference up to the root object will also contain a reference to it. So the idea here is that if we didn't say it's supposed to go to all the way to the root, like maybe it's something tied to a very specific game object, or something that there's many of, like here is our NPC, and then we have like a dozen NPCs, but each NPC has a health status bar, so we're updating it to let it know if anything wants the health status bar, get this. But that's not supposed to go to root. That's just supposed to go to that local unit, that local NPC. Okay, so same thing with checks for parents, and it also sets the value in the parent. Again, passing in that toRoot is true. I could just say true here or toRoot. They're the same thing right now, so it doesn't really matter. Okay. All right, so that will actually set a value all the way down to the root. So if it's something like a manager or a service where there's only going to be one instance that everything in the game can tie to, that will likely go all the way down to the root. For things that influence one item where there might be dozens of that item, you want that isolated to that individual, to the individual items. Okay, so there's my set function. Simple set and get where we're just passing in a value. Now in this case, we don't really need late binding. I mean, that could be an argument for later, but in this case, I don't think so. We're referencing Unity objects. These are components that are already established inside of here. So why create a reference to it if it doesn't already exist? In that case, we would need something more like a pool or a factory. And I think it'd be entirely reasonable to add factory classes and pools. But for right now, for the constructor, I don't see any reason we need to construct it. We just need to know where it is. This also allows us to have the flexibility in our prefab, since prefabs can't contain scene references, that it'll lose it when you try loading it back into a scene. So that's a way to, the locator service is a way to allow that to continue to work, because as you put a new element in, all of those items that are getting wired up into its local locator, there might still be some global ones going in. Okay. So now we've got that. That's our locator. And we set our parent. Same thing for set parent on here. We check to see if we've already checked for parent, then fine, whatever. We don't need to do it. There is an assumption on this code that is basically clarifying if we're not assuming that we're going to add new parents in this. We're not assuming to add new objects above. We are assuming that we can add new child objects to this. So if you have some code in here where you change the root element that things are attached to, which you very well could do, that could be an entire way of organizing your scene in this system, where I have my root, and here's my root, and I could have, this is a test environment root, and here is live environment root. And I just take the game objects, the main game objects here, and just drag them from one into the other. And then my root locator will have all of that specialty locator stuff set up for it that makes them unique. Okay, anyway, so I do the same check for parents. I grab the parent, check for, try to get another locator above it, etc. And then whatever the case, whether it's null or not, I check for parent. I say that we've checked for the parent at least. So we don't have to keep repeating this process every single time this gets called. Just the first time that we create a new setup for locator. All right. Now we have score maker. How do we actually use this? Okay, so first of all, you'll notice there are no static variables in here. On this one, I'm saying, okay, get locator. On this one, we needed a special get locator function. So this so far requires a little bit of work. And so that's a question of how you might want to question how valuable it is, because anytime that we have to start adding boilerplate, maybe it's not as useful. This could also be something where we create a base abstract class called locator behavior, where it already has this functionality right here built in to it, and so we can always call get locator under the hood, and we don't have to rewrite this function all the time. Okay, but this should be a local instance of it. This shouldn't be a static variable or anything else. Technically, we could do this statically, where if it didn't have its value anymore, this function will go find it again. It does the be locator where it passes in what our current understanding of locator is, which could be null, and the transform we're on. So it can traverse that. It doesn't need to, it's going to be able to check all of the objects, and that code doesn't need to be associated with this specific game object. It'll figure it out. Okay, and it returns the locator that it's aware of. It's still possible that there's literally no locator service. So if it does, then our next code here is going to get a null reference exception because the get function doesn't exist for an empty locator, or null locator. Okay, but we are asking to get this reference. Once we get it, this is the important part. We take that reference and we put it inside of a field that Unity can serialize. Awesome, that's it. Once we've done that, it doesn't matter if we still have our reference to locator anymore. We don't need it. We already have a reference to the scorekeeper. Unity will maintain this reference for us. Okay, great, this one works. Now let's also check that other one, which was the scorekeeper. Scorekeeper is basically the same thing. You can see in this one for the locator, I told it to hide it in inspector. I don't need that to be known. It's a public field, so it can be serialized. I could also have it private and then mark it to serialize the field and have it hide in inspector. So again, this is not to get like final code and make this a pretty architecture. This is a test run. Okay, so same thing on this one. We get our locator. So I have a function that I'm repeating, and that might be a consideration for simplifying, again, by creating something like a locator behavior, for instance. Okay, and then we have our objects, and we get our locator to begin with right away, and we set we don't keep it. The only time that we need this is other things you're going to be calling this object, so we don't actually need to go get anything else later. When we first wake up, we are going to set ourselves, and this is on the awake function. Important key thing anytime you're using a locator service, identify and clarify, like, this is now law in your project, that the awake function is where you are setting up services, where those services come online and become available. And then your start functions are where you can expect to go get them. All right. So on this one, we are setting it for B Scorekeeper. Now I'm not using an interface here. If I used an interface, I would lose that reference to an interface. Actually, maybe not. That'd be something else to test in specific. I was testing interfaces with static. I think I did a local interface test, but I don't remember a specific test, so I'll go look that up later. Anyway, we are telling it, hey, that we are the scorekeeper. We're passing in this. And true, when I put the comma here, that is for to root. Is this going to go all the way to root? It's going to go into our locator and then into whatever, if there's any locator above that, all the way up to the root element of the scene. Okay, so this works for that. And then finally, anytime someone adds a score, we just add the variables and we set the text. But this function works. So if I created I could do this as a locator behavior where these functions are just gone. And then we effectively have the get locator, set variable, etc. Could even just have a couple functions inside of the locator behavior that's simplified even further, where you just have a set function and a get function. All right. Anyway, so that's working. There is one other thing that I figured I should show you, because in the code I'm using this. I'm using a dictionary, but I'm using a serializable dictionary. Now, this is a custom class that I built. It's inside of the code. Again, you can check the code reference. This is provided by Unity. At least what this is based on is provided by Unity. If I go into this code, it's actually based on here. I have the reference here, so I can pull this in. All right. So on this one, let's see, the iSerialization callback receiver, I'm actually taking advantage of their serialization break for this. I'll go into this a little bit more later, but if you want to, the link was in the code and you can check it out or just search for the iSerialization callback receiver. It comes with two functions, the on before serialize and on after deserialize. So what they did is the dictionary isn't supported, where they just have ints and strings, and instead they created two lists, a list of keys and a list of values. So right before they serialize, they actually clear out the keys and values, and then they go through everything in the dictionary and set them. There's a couple minor modifications I did for performance increases on mine, but nothing major. And then same thing for after deserialization, it resets the dictionary and then it goes back through and finds all the keys and values and adds them back to the dictionary. That way the dictionary, what we're using, always works. So the difference on my code to that one is over here. Let me bring this down just a little bit so we have some more code visibility. I have two private fields that are serialized. Here's a list of keys and a list of values. Next, I've got the function for on after deserialize. Now, I will say this. I did have to go through several iterations of this class and modifications to it because I kept getting various errors on the on-after serialization and deserialization. For instance, one of the things is the serialization or deserialization process is part of what actually sets these to their basic null object or empty objects to begin with. So they weren't available unless you specifically call them out. Whereas if you create a list inside of Unity, or no, it was the array that it generates. But anyway, so inside of here I have those being stored. Also, another thing, if you weren't aware, you don't have to use like K or T for your generic types. You can actually just put a specific word in place. Now, I usually use full caps to identify that this is generics. But that makes it a heck of a lot easier. Like, okay, we have our keys and our values. It's very easy to understand what the types are for now. So by all means, please just actually write out what that is now. Okay, so we're taking over those two key functions, which this is brought on by the iSerialization callback receiver. So on this one, we're doing the exact same thing. I'm saying, okay, for every single one of the keys in here, we are going to add it to our list of keys. This is to our dictionary. We're adding it to our dictionary. One additional change I could make right here is I could say, let's see, this dot, and I forgot the term for it, but set range. When I'm initializing it, I know how to do it. I remember how to do it through constructor, but not through the object by itself right now. But when you're constructing it, you can set the length of it. So I didn't do that here. Have to see if I can set what the range length is. But anyway, then I clear out the extra data because I don't need to hold all these duplicate references. These ones are basically unused except for serialization. Same thing on the on before serialization. In this one, I'm actually passing in the count that we have so that these are already initialized. It has those arrays established and doesn't need to produce new ones or duplicate memory. And then we go through every pair in the dictionary in this because we are literally just inheriting from dictionary and from the interface for serialization callback receiver. But we go through every pair in this and add the pair key and the pair value. And the dictionary works. It ends up storing it because the lists are stored. We don't use them when it's running. These are private, inaccessible outside of here. So on the B locator, I'm just using what effectively is a dictionary. All right. Any thoughts or comments, please add them. Let's get a discussion going on this. There's a lot of different directions that I can start taking this now. Cleanups and other potential areas, like what else should I talk about? Should I dive into dependency injection? Are there other areas, flyweights? Talk to me.